Here's here's the original Pringles can. Here it is, right over here. Except it's, I suppose I should have made it, you want it color coordinated? Anybody care? I think we needed color coordinated. It's red, because it's the original flavor. If it's a little wider than it actually is, I guess, but whatever. Now, there's a part on top here that's extra, right? This is the original can. If you ate the entire original can, what percentage of that can have you eaten? 100%, right? If I tack on this, here's the extra part that they give you on the top, right? Okay, so there's the extra part. Maybe it's a slight bit more, because how much should that be if I fit it into the other part, if it says bonus 25%? How should that fit into here? This should be about a quarter of it, right? Now, I maybe made it a bit too big, but we'll go with that. What if you ate all of these chips now? Oops, if you ate all of those chips now, what percentage of the original can did you eat? What percentage of the original can? Like you ate a whole regular can plus an extra 25%, right? So you actually ate 125% of a regular can. When you work with percentages, it's not an absolute amount. I'm going to give you 100% of the money I found on the floor today. Isn't that generous of me? I found nothing. So you get nothing. If somebody else out in the hallway said, hey, I'm going to give you 100% of the money I found on the floor today, and they happen to find $10,000 on the floor, you get $10,000. 100% from me is different than 100% from somebody else. Percentages are relative to what you're comparing them to. It's a comparison. Okay? Question? I realize that's on task, but I don't think for regular circulation they make a $10,000 bill. Now, I tend to be someone who gets off topic a lot. I went to the Canadian Mint this summer, and they make lots of cool stuff. But one thing they made was I think it was a $1 million gold coin. Like, it was huge. It was like half a meter across. It was like an inch thick. It was a $1 million gold coin. I don't think the gold in it was worth $1 million, but that was the face value on it. It said $1 million. It was very cool. No. Well, when they make coins that expensive, and now we're really wasting the time here, but when they make things that expensive, it isn't, like the face value might have been, I can't remember, $5,000 or something like that, but it cost, no, actually, you know what? I'm saying the wrong thing. It said $1 million on it, but to buy it, it cost, I don't know, more than that. I can't remember the exact numbers, but yes. They only made about 3 or 4 of them, and I don't know who the people who bought them are, but no, the gold in the coin is not, like the face value is less than the gold in the coin, so you have to pay more for it. But they put a face value on it in case the value of gold drops to nothing, it's still worth something. I don't know. It's kind of complicated, but if you're ever in Ottawa, it's a very cool thing to do is go see the Canadian Mint. It's got really neat stuff in it. Anyways. The mint, well, they talk about the word mint, minting. You mint new coins. I don't know, that's the word for it. That's the verb to say you're making new coins, like you stamp them out. It's the mint. Actually, they make them all in Winnipeg. The one in Ottawa is now just they make the special ones and the $1 million gold coins and the little specialized collector ones. That was a minute of good video for somebody watching at home. This is about representing percents using grids. I think actually, now that I think about this, we are going to kind of partly do this together here. Representing percents like 100, like 1%. 1% is 1 square on the grid, right? If you want to show 3/4 of a percent, 3/4 of a percent, this is less than 1%, right? If I said I am going to give you 3/4 of 1% of what's in this box, how much are you going to get, even if the box is full? Not a lot, right? You might get a little piece of one of the granola bars. It's a very small part. 0.75%. If I was going to represent that on here, how do I represent that? If this square, you notice that this is like an enlarged version of this little square. How could I show that on here? What do you think? Yeah, if I divided it up and color in 3/4 of the square here, right? There's 0.75%. Okay, 0.75 of one square. It's less than 1%. If you wanted to, this might be a little bit hard, but 0.37%. People have trouble with this because they get confused and say 0.37%. Is that like 37%? Well, what's the difference between this and this? Are those the same? Are they? 0.37 is like 37%. Because 0.37 would be, how much here? 0.37 or 37% would be this much. And 7 more, right? There's 37%. If I wanted 0.37%, 0.37%, this is less than 1%. How would I have to show that with that tiny little square there? Is it half of this? Half of that would be 0.5% or 0.50%. Is it like a quarter of one of those little squares? Is it more or less than 0.5%? It's less. Is it more or less than 0.25%? It's more. If I really wanted to do this, and this is why you haven't been actually asked to do it, it's asking you what would you do? What would I have to do here? I'd have to take this and divide it up into on 100. What I could do is do this actually. I could, let me see, I go way down here. Where is it? Where's my little grids? I've completely lost them. There they are. Okay. I could say if I want to do 0.37%, I'm doing, I won't shade it in. I'm just going to circle this and say this is expanded to here, right? Here's what I'm showing here. How much of this other square here is it? 0.37%. It'd be 37 of these, right? Or in other words, if you were to draw it here, the other way you could do it is just say, well, I'm going to show this here as a square like this, and I'd have to divide it up into 100 things, which is going to be a mess here, so I'm not going to do it, and shade in 37 of them. I'd have to take the little square and shade in 37 parts of it. 0.37% is a very small number. Okay? What I would like you to do here, I'm going to stop this. What I would like you to do is this question. In wherever you are working right now, do the reflect on your findings. Basically, I want you to write an explanation for yourself for how do you use percent grids, those grids to represent percentages greater than 100, and how do you use grids to represent percentages between 0 and 1? And how do you do it if you represented mixed numbers greater than 1? As in, we just looked at a bunch of those. What was the one we looked at that was greater than 100? What was the percent we looked at greater than 100? It was what? 130, right? 130% because we were talking about the thing there. Or actually the more interesting one was the Pringles can, which was 125%. Whichever one. What was the one that we looked at that was between 0 and 1? 0. We looked at a couple different ones. We looked at 0.37% or we looked at 0.75%. And the one that was a mixed number was my save percentage goalie one, which was 89.5%. 0.895. You answer those questions right now for yourself. And then I would like you to look at the examples. Actually look at them and see what they're showing you. I'm sure you can go through these pretty quickly. Percentage grids for the first one. they have done them for you, and you just need to say what percent does each one represent. That should be pretty quick for you. Representing them on a grid is more difficult because you need the grids. What you could do here is, because I haven't given you grids yet, I will give you some later, but you could describe how you do this. When you do this show, you know. Describe. I don't want you to have to actually draw some grids for that. Okay? If you want, you could actually make little grids, so that's going to take a long time. I need to